Hello students, welcome to CREATA classes and also welcome to our lecture on one-shot video on the topic Some Applications of the Trigonometry, chapter number 9 for class 10th students. This lecture we have divided into the following part. Firstly, we will discuss all the formulas and the data related to the chapter, all the formulas that will be used to solve the question. After that, we will take down the concepts, the definition, the theory, everything from very basic level to the advanced level. Everything we will do using the visual tools. After that, the main part, we will do the various cases on which the questions will be asked. Around 8 to 9 different cases we will take down on which the questions are generally asked in the examination. This will help you identify the difference between the different type of questions and how to approach the questions. Lastly, we will take down the various questions on the different cases. We have covered every cases and every questions related to the different types that can be asked in the examination. And also we are having the PDF of the concept and the formula list. Check the link in the description. Also we are having the quiz in which you can take down the various questions and check your level of understanding about the topic. Okay, so all these things we will cover in this lecture. So without taking any further time, let's start with the lecture. Here it is, and best of luck. The chapter Some Applications of the Trigonometry is an extension of the previous chapter, the chapter number 8, the Introduction to the Trigonometry. The concept of the previous chapters are also applicable in this chapter. So firstly, let's understand what are the concepts of the previous chapter that will also be applicable in this chapter. First, these are the trigonometric ratios formula that will be used, and this is the trigonometric ratio table that will also be used in solving the question. The detail of these formulas and the trigonometric ratio table, the lecture link is given in the description, check it out. The most used trigonometric ratio is tan theta, and especially tan 30 degree, tan 45 degree and tan 60 degree. These three values you must know. Tan 30 degree it is 1 upon root 3, tan 45 degree it is 1, this is very interesting, and tan 60 degree it is root 3. These three values you must know. Other value you can easily solve as we have discussed in the previous lectures. So these will be used to solve the various questions related to the height and distance. Further, one thing that you should also know is that whenever a right angle triangle is given and one angle and any of the one side is given, you can easily calculate the two remaining sides. For example, the angle theta is given and one side say perpendicular is given. You can easily calculate base using the tan theta. Tan theta is perpendicular upon base. Further, you can also calculate the hypotenuse using the sin theta, that is perpendicular upon hypotenuse. So the point is that once you know the angle theta and any of the one side, you can easily find the two remaining side. This you should know. Let's move further and let's understand the basic terms related to this concept. The concept name is height and distance, height and a distance. Let's understand some of the basic terms with various examples so that your understanding about the topic can be further enhanced. The first term is the line of sight. To understand this term, let's take a building and one person is standing in front of that building and that person is looking at the top of the building. The line of the sight is the vision of that person. So the imaginary line that is forming through his vision is the line of sight. To understand this concept, you can take an example that person is having a laser in his eyes. So that person is emitting laser from his eyes to the top of the building. Wherever that person is seeing, the laser is also moving in that direction. So that laser beam is the line of sight. The imaginary vision line is the line of sight. Got it? And if we make an angle from that line of sight with respect to the horizontal line, then that angle will be called the angle of elevation. Angle of elevation when you are looking upward. Got it? We have taken the horizontal line. Do not be confused it with the vertical line. This is the angle, not this. During taking down the question, as per the different scenarios, sometimes this angle is given. So students generally confuse, this is not the angle of elevation, this is the angle of elevation. When we are looking upward, the angle formed is the angle of elevation. When we are looking downward, the angle is angle of depression. That we will do the next topic. Okay, angle of elevation when we are looking upward. So you got the term line of sight and the angle of elevation. To further understand this angle of elevation, let's take 2 to 3 different cases in the same scenario. For example, the person is seeing a plane flying in the sky. So this is the line of sight and this is the angle of elevation. For example, this angle is 60 degree. So our angle of elevation in case of the plane is 60 degree. Further, a kite is also flying in the sky. That person shifts his vision from the plane to the kite. Now our angle of elevation has been changed. This angle is 45 degree. So we will say the angle of elevation in case of kite, the object kite is 45 degree. Got it? Further, next to that person, a building is also there. This is the building. Now that person shifts his vision to the top of the building. Now again the angle of elevation has been changed and this angle is 30 degree. So we can say our new angle of elevation with respect to the building, the top of the building is 30 degree. So this is the angle of elevation and it changes as the object change. Firstly, the object is the plane, second the object is the kite, and lastly the object is the top of the building. Got it? So this is the concept. Let's move to next term, that is angle of depression. To understand this, let's again take a building, but now the person is standing on any of the one floor of that building and that person is looking downward to an object. For example, here the object is a football. This line will be the line of sight, the imaginary vision line. So this line is the line of sight and the angle formed between the horizontal line and the line of sight is the angle of depression. Angle of depression when we are looking downward and angle of elevation when we are looking upward. These are the two angles, angle of elevation and angle of depression. Again, note that the angle of depression is formed with respect to the horizontal line. This is the horizontal line, not the vertical line. So this angle will not be the angle of depression. This will be the angle of depression. This is a common mistake done by the students. Further, these two angles will be equal to each other. The case of transversals you can apply, these two are the horizontal line which will be parallel to each other. So this will be the transversal. So these two angles will be equal to each other. Just an concept to make the question easier for you. Now let's see how to approach the various questions. We are having 4 to 5 different steps that you have to apply in the sequence to solve the question. Let's see what are these steps. The first step and the most important step is the identification of the triangle. You have to visualize a right angle triangle in the given figure. Firstly, you have to observe the given question. Once you observe the given question, you have to identify a right angle triangle out of the given scenario. This is the first step and one of the most important steps. Take most of your time in this step. Observe the question in very detail and just draw an imaginary right angle triangle about that scenario. This is most important, and as we take different questions you will understand that how to take out the different right angle triangle out of the given scenario or out of the given question. This is very important and also very interesting. You will love this. For example, we are having a plane in the sky, so this is the imaginary right angle triangle. This person is now seeing a kite, so now this is the right angle triangle. This person is seeing the top of the building, so now this is the right angle triangle. This person is seeing the football on the ground, so this is the right angle triangle. Got it? This is the first step. You have to identify the right angle triangle out of the given scenario or the given question. The second step is identification of the trigonometric angle. Why? Because we cannot directly apply the trigonometric ratio until and unless we do not know the trigonometric angle. Because the trigonometric angle will govern which are the trigonometric sides. So one by one, the second step is the identification of the trigonometric angle. This is important. Let's understand why. This person is looking downward at the football or the object, so this triangle will be formed. Suppose the angle of depression is given in this case as 30 degree. So you can take this as 30 degree, so this angle will also be 30 degree. We can take this angle as a trigonometric angle and apply the trigonometric ratio or apply the trigonometry in this right angle triangle. Or we can take this angle also as a trigonometric angle and apply the trigonometric ratios. The formula of trigonometric ratios in both of this case will be different. Got it? The trigonometric ratio formula, if we take this angle, will be different, and if we apply the trigonometric ratio with respect to this angle, it will be different. Why it is different? We have already covered in the previous lecture. If you want to refresh the concept, check out the link of the lecture in the description. Okay? Got it? The second step is the identification of the trigonometric angle. The third step is the identification of the trigonometric sides with respect to this trigonometric angle. What are the trigonometric sides? The first is the perpendicular, which is the side opposite to our trigonometric angle. Second is the hypotenuse, which is the side opposite to 90-degree angle. And the third remaining side is the base for this triangle. Okay? The third step is the identification of the trigonometric sides. The fourth step is the application of the trigonometric ratios. Once you got the trigonometric sides, you can easily apply the trigonometric ratios. These all are the trigonometric ratios and these are the formulas. Got it? No need to note down this step. As you take down more and more questions, you will understand why these steps are in this order. Okay? So these steps we will follow to solve the height and distance questions. So we have done the basic understanding of the chapter. Let's move to the questions. Before taking down the different questions, you must understand what are the different type of cases that can be formed out of different scenarios. So the most important thing is to visualize the question. Once you are able to visualize the question, you can easily identify a right angle triangle out of the given scenario. Now we will take different like 8 to 9 different cases on which the different type of questions can be asked. Do not worry that it is 8 or 9 different type of cases. These are very simple cases. Once you understand the basic, you will be able to solve any of the question related to the concept. Believe me. So let's take the case number 1. Do not worry, it will be very simple. Case number 1. Case number 1 is a simple case in which we can easily identify a single right angle triangle in the given scenario. We are having a single right angle triangle. For example, we are having a chimney in front of a girl. That girl is looking at the top of the chimney. By doing so, we are making an imaginary right angle triangle from the eyes of the girl to the top of the chimney. This is an imaginary right angle triangle. Once you have identified this right angle triangle, you can easily apply the trigonometric ratio formulas based on the given dimensions in the question. What you need only the trigonometric angle and any of the one side. Then you can find any of the missing dimension. Note that only two things you need. First, the trigonometric angle that must be given in the question. Second, any of the one side of the triangle that will also be given in the question. Okay? Rest, when we take down the different questions, you will understand how to apply the trigonometric ratios formula. Further, in the circle, this cyclist is doing the cycling on the rope. So again, we are getting an imaginary right angle triangle. A storm is going and this tree has been fallen down. The top of the tree is touching the ground. This is also a right angle triangle. These different type of scenarios will be given in the question and you have to imagine the exact scenario which is given in the question. And you have to extract a right angle triangle. Mostly the figure will also be given in the question, but do not depend on the figure. It may or may not be given in the question. The more you are able to visualize, the more you are easily able to solve the question. So this is the case 1, the simple one right angle triangle. Let's go to case 2. In the case 2, we are having two right angle triangle. The case is, for example, we are having a flag on the top of the building, and from the point on the ground, we are looking at the top of the building as well as top of the flag. Here, are you able to observe these two right angle triangle? One triangle is this big one and second is this small triangle. So here the important thing is that both the triangles are sharing the common base. This is base in both the triangles. So both the triangles are sharing the common base. You can apply the trigonometric ratios in one of the triangles and you can get the base, and you can put the base in the second triangle and again you can apply the trigonometric ratio formula. Got it? Two right angle triangles sharing the common base. Note that these cases are just for your basic understanding of the topic. Still, we have not done the questions. These cases are just to give you the glimpse of what we are going to cover and what this topic is looking like. When we take down the questions, we will take all these cases and you will understand it more in very detail. Okay? These are just the cases for your basic understanding. Don't feel pressure that how the triangle are formed, what are the angle, how you will solve it. As we take down the questions, you will learn it. Okay? Moving further, here again in the case 3 we are having two right angle triangle with the common perpendicular. Let's see, suppose we are having a building or a tower and we are having a sun behind that tower and that sun is casting the shadow of that tower on the ground. After some time the sun has risen to the different altitude. Now the length of the shadow has been shrinked. So by this we are getting two right angle triangle in the given scenario as per the position of the sun. So in this case we are having the common perpendicular in both of this triangle. We can apply the trigonometric ratio in any of the one triangle and find the perpendicular and put that perpendicular in the second triangle. So this is the approach that you will use in solving such type of questions. Moving next, this case belongs to the angle of depression when we are looking downward. In the previous cases, we have seen the angle of elevation when we are looking upward. We are elevating our face, the angle of elevation. Now we are looking downward, the angle of depression. Suppose we are having a lighthouse. Person at the top of the lighthouse is looking downwards toward the ship in the sea. So that person is looking downward. So the angle formed is angle of depression. These are the important question. The trick or the approach to such type of question is the use of transversals in the parallel line. Yes, you have to use the concept of transversals. You must be done in the previous classes. The concept is that the angle of depressions are formed at the top and our trigonometric triangles are at the bottom and our trigonometric angles are also at the bottom. Somehow you have to transfer the angle at the top to the bottom part. That you will do with the help of the transversal. You can take these lines out of the figure. Here these two lines are the horizontal line, so will be parallel to each other, and this is the transversal. So these two angles are the alternate interior angles which are equal in the case of transversals and the parallel line. So these two angles will be equal to each other. Similarly, in the second case, these two lines are parallel and this is a transversal. Again, these two angles are the alternate interior angles which are equal to each other. So by using the transversal, we have transferred the angle at the top to the bottom part. Whenever we are having the angle of depression, this concept will be applicable. Just use the simple transversal and the alternate interior angle and transfer the angle at the top to the bottom part. Rest is just the application of the trigonometric ratios. So this is the case of angle of depression. Moving further, case number 5. This is one of the important case and generally the questions are asked based on this case. The concept is that one person is on the ground and this person is seeing an object flying in the sky. Maybe a balloon, maybe a bird, maybe a kite, anything which is flying in the sky. After some time, that object has changed its location, it has moved forward. Now that person is again seeing that object. The angle of elevation has been changed. By doing this, we are getting two different triangles. From the first case, this is a triangle. From the second case, this is a triangle. So we got the two triangles, and these two triangles are not having the common perpendicular nor common base. You have to apply the trigonometric ratios formula in the two triangles separately. Okay. The question may also extend. The balloon has further moved forward and you are getting the third triangle. Anything can be given in the question. Once you are able to visualize the question, you can extract a right angle triangle from that question. You will be able to solve any question. After you got the right angle triangle, rest is just simply applying the trigonometric ratio formula. Sin theta, cos theta and tan theta. Mostly tan theta will be applicable. And within tan theta, tan 30, tan 45 and tan 60 will be mostly applicable. Okay. Further, let's take the next case. In this, we are having two buildings, one tall building and one the smaller building. And we are looking at the top of the tall building, from the top of the small building and from the bottom of the small building. By doing so, again we are getting the two triangles. These are the two triangles. Here these two triangles are sharing the common base. The base is not overlapping with each other, but if we move the triangles, the base is common in both the triangles. So again we can apply the trigonometric ratio in both the triangles and we can equate bases of both the triangles. Okay, so this strategy we will use. Moving further, in the next case, we are having a tower and a building. From the bottom of the tower, we are looking at the top of the building. And from the bottom of the building, we are looking at the top of the tower. By doing so, we are getting two right angle triangles. These are the two right angle triangles. Again, these two triangles are sharing the common base. So again, you can apply the trigonometric ratio in both the triangles and equate the bases in both the triangles. Got it? So these are the different type of cases through which we can have different type of questions. Okay. Apart from this, you should also know the formula of speed and distance. Speed is equal to distance upon time. This may also be used in some of the questions. Okay. So these are the different cases through which we can have different type of questions in the exam. So we will take different type of questions based on each case so that you can understand the type of questions that will be asked in the examination. So this is the approach that we will use in this one shot video. So let's start with the questions. And one thing that you should notice that we are having a PDF of the formula and the concept list. Go to the description and check out the link for the PDF of the formula. Okay. Further, we are also having a quiz for this chapter. Go to the description and check the quiz. There you will get the different type of questions to check your level of understanding about the concept. So these two you can check in the description. So without taking any further time, let's take the question number 1. A circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degrees. So this is the question. First step, we will observe the question and we will try to identify a right angle triangle in the given scenario. In the given question, a pole is given, this is a pole, and a rope is tied to the top of the pole to a point on the ground. So this is the rope which is tied to the top of the pole and the other end is tied to the ground. The length of the rope is given as 20 meter and this angle is given as 30 degree. A circus artist is climbing this rope as an art performance, and in the question we have to find the height of the pole. So this is a scenario given in the question. Are you able to observe a right angle triangle in the given scenario? Yes, here this is a right angle triangle. Let's mark the 3 vertices of this triangle as A, B and C. Here AB is the height of the pole that we have to calculate and AC is the length of the rope which is given as 20 meter. Our angle, that is angle theta or the trigonometric angle, is given as 30 degree. Let's identify the 3 trigonometric sides of this triangle. Firstly, the perpendicular. Perpendicular is the side which is opposite to our trigonometric angle. Here trigonometric angle is angle 30 degree or angle C. So the side opposite is AB. So AB is the perpendicular for this triangle with respect to our trigonometric angle 30 degree. Further, hypotenuse is the side which is opposite to 90 degree angle. Angle B is the 90 degree angle. So AC is the hypotenuse for this triangle. And the last remaining side BC is the base for this triangle. Got it? So we got all the 3 trigonometric sides for this triangle. Here hypotenuse is given as 20 meter and in this question we have to find the perpendicular AB. So what is the relation between the perpendicular and hypotenuse? Which trigonometric ratio will be applicable? Here sin theta will be applicable, which is perpendicular upon hypotenuse. Perpendicular we have to find, hypotenuse is given in this question. And also angle theta as 30 degree is given in this question. We got sin 30 degree is equal to AB upon AC. So let's refer the trigonometric ratio table for the value of sin 30 degree, which is 1 by 2. And AC, that is the length of the rope, is given as 20 meter. On solving, we got AB as 10 meter. AB, the height of the pole. So we got the answer of the question number 1, that is the height of the pole AB is 10 meter. We have done with this question. Let's move to the next question. The next question is, a tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degree with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meter. Find the height of the tree. So this is the question. Firstly, let's observe the given scenario in this question. A tree is given in this question and due to the storm, the tree has been broken down and the top of the tree is touching the ground. Due to the storm, the tree has been broken at one of the part and the top of the part has been fallen down and it is touching the ground. And the angle that the top portion is making with the ground is 30 degree. This angle is 30 degree. And the distance between the foot of the tree to the point where the top touches the ground is given as 8 meter. So this distance is given as 8 meter and this angle is given as 30 degree. And in this question, we have to find the height of the tree. Height of the tree is basically composed of two parts. This part, the remaining part of the tree, and the broken part, this part. Firstly, let's mark the point as A, B and C. Here the length of the tree is the distance BC and the distance AC. If we take the standing tree, the complete length of the tree is basically AB. And due to the storm, the top portion or one portion of the tree has been fallen down, which is AC. So the complete length of tree that we have to calculate is BC plus AC. So basically, this question is asking us to calculate the distance BC and the distance AC. So this is the complete scenario which is given in the question and what the question framer is asking. Let's solve this question. The first step, we will identify a right angle triangle in the given scenario. Are you able to identify the right angle triangle, the triangle ABC in this figure? This is the right angle triangle. The trigonometric angle for this triangle is given as 30 degree. The one side AB is given as 8 meter. The angle, the trigonometric angle is given and one side is given, and we know once we got the angle and any of the one side, we can easily calculate the two remaining side, the side AC and the side BC, which the question framer is asking in the question. Got it? Moving further, let's identify the trigonometric sides. Here BC is the perpendicular as it is opposite to the trigonometric angle. AC is the hypotenuse as it is opposite to 90 degree angle, and the side AB, the remaining side, is the base for this triangle. Here AB, that is base, is given as 8 meter and we have to calculate the perpendicular and the hypotenuse. Firstly, let's find the hypotenuse, that is AC. We know base, we have to find hypotenuse. What is the relation between the base and hypotenuse? Which trigonometric ratio will be applicable? Here cos theta will be applicable. Cos theta is base upon hypotenuse. So cos 30 degree will be equal to AB upon AC. AB, it is given as 8 meter, and what is the value of cos 30 degree? Let's refer the trigonometric ratio table. It is root 3 by 2. So we got root 3 by 2 is equal to 8 upon AC. Let's find AC. AC we got as 16 upon root 3. One part of the tree or one part of the question we got as 16 upon root 3, that is AC. Let's find the second part, that is BC, which is the perpendicular for this triangle. And what is the relation between the perpendicular and the base? Which trigonometric ratio will be applicable? It is tan theta. Tan theta is equal to perpendicular upon base. You can either use the tan theta or you can also use the sin theta. Sin theta is perpendicular upon hypotenuse. Perpendicular is the missing side and hypotenuse we have just calculated. You can use the hypotenuse to find the perpendicular, or we can use the base to find the perpendicular. Either way you can go. We are going with the tan theta. So tan 30 degree will be equal to BC upon AB. And what is the value of tan 30 degree? That I have told in the starting to remember. Tan 30 degree is 1 upon root 3. You should know tan 30 degree, tan 45 and tan 60. These three values are very important. Further, AB is given as 8 centimeter. On solving, we got BC as 8 upon root 3. So we got the value of AC and BC, that is the two part of the tree. And in the question, we have to find the height of the tree, which is BC plus AC. So 8 by root 3 plus 16 by root 3. Let's take the LCM as root 3. We got the answer as 24 upon root 3. Let's multiply the numerator and denominator by root 3. We got our answer as 8 root 3. That is the height of the tree, 8 root 3 meters. Got it? Simple question. If you are able to visualize the question, you can easily solve the question. Visualization play very important in the height and distance questions. We have done with this question. Let's move to the next question. The question is, from a point P on the ground, the angle of elevation of the top of a 10-meter tall building is 30 degree. A flag is hosted at the top of the building and the angle of elevation of the top of the flag staff from P is 45 degree. Find the length of the flag staff and the distance of the building from the point P. So this is the question. Let's observe the question. In this question, a building is given and on the top of the building a flag is given and also a point P is given on the ground. From this point P, the angle of elevation of top of the building and top of the flag staff is given. Flag staff is basically the complete flag. The angle of elevation of top of building is given as 30 degree and the angle of elevation of top of the flag is given as 45 degree. So these two angles are 30 degree and 45 degree respectively. The concept of angle of elevation when we are looking upward. Okay. Further, the height of the building is also given as 10 meter. And in this question, we have to find the height of the flag staff. That is height of the total flag. The length of the complete pole of the flag. So this is a scenario that we got out of the question. Let's mark the different point as A, B and D. Further, are you able to observe the two different triangles in this scenario? The first triangle is PAB, this triangle with the angle as 30 degree. And the second triangle is PAD, this big triangle whose angle is 45 degree. Let's take these two triangles out of the figure just for the comparison purpose. Here PA is common in both the triangle. Okay, we got one side as common in both the triangle. So we can solve both of these triangles separately and we are having AP as common, which will help us in equating the output of both the triangles. You will understand it more as we take down the solution. Further, in this question, we have to calculate the length of the flag staff. That is, we have to calculate BD, this distance. The strategy that we will use is, from the first triangle, the big triangle, we will calculate the distance AD. And from the second, the smaller triangle, we will calculate the distance AB. And AD minus AB, we will get the distance BD. That is the answer, the height of the flag staff. So this approach we will use. So let's take the smaller triangle. The triangle with angle as 30 degree. Let's solve this. Firstly, let's identify the various trigonometric sides. Perpendicular is AB and base is AP and hypotenuse is PB. Okay. And AB, the height of the building is given as 10 meter. So can we find the base of this triangle, which is common in both the triangles? Base and perpendicular both are linked through the tan theta. Tan theta is perpendicular upon base. So tan 30 degree will be equal to AB upon AP. Let's find the value of tan 30 degree through the trigonometric ratio table. Tan 30 degree is 1 upon root 3. Let's put AB as 10 meter. Let's solve. We got AP as 10 root 3. Let's replace root 3 with 1.732. We got AP as 17.32 meter. That is the base of the triangle. Base of both the triangles. Got it? Now let's take the big triangle, which will help us in finding the length of the flag staff. Here for this triangle, AD is the perpendicular and AP is the base. And base in both the triangles are common. So let's put AP or the base as 17.32 meter, the same base of the previous triangle. Again, here the perpendicular and base are coming into the picture. So tan theta will be applicable, that is perpendicular upon base, which is tan 45 degree is equal to AD upon AP. Let's refer the trigonometric ratio table for the value of tan 45 degree, which is 1. And let's put AP as 17.32. We got AD as 17.32 meter. Whenever we are having the angle as 45 degree, tan theta will be applicable perpendicular upon base and tan 45 degree is equal to 1. So perpendicular and base will be equal to each other in the case when angle is 45 degree. Got it? So here angle is 45 degree. So perpendicular and base will be equal to each other. So we got the perpendicular or the AD as 17.32 meter. Got it? Here in the question we have to calculate the distance BD, that is the height of the flag staff. And we know BD is equal to AD minus AB. And we have just calculated AD as 17.32 meter. AB is the height of building, which is given as 10 meter. Let's put the value. We got BD as 7.32 meter. That is the length of the flag staff is 7.32 meter. That is the answer of this question. Got it? This type of questions you may see in the real exam where we are having two triangles. Here these two triangles are sharing the common base. So you have to keep this in mind. You can equate the output, the trigonometric output of both the triangle, as one side is common. Similarly, if you are having a case in which the perpendicular is common, there also you can use a similar philosophy but with the perpendicular as common. As we take down the different question, you will understand it more. Got it? We have done with this question. Let's move to the next question. The question is, the shadow of a tower standing on a level ground is found to be 40 meters longer when the sun altitude is 30 degree than when it is 60 degree. Find the height of the tower. So let's observe this question. This question is talking about a shadow of a tower. So firstly, let's take a tower. Let's assume the height of the tower as AB. A is the top point and B is the bottom point. So this is a tower and this tower is casting a shadow. And in the question, the shadow of this tower is given at two different times when the sun is at two different locations. In the first case, the sun is at an altitude of 30 degree and it is casting the shadow. So here this angle is 30 degree, the angle with respect to the sun. Let's mark the shadow as BD. We have taken a point D. BD is the length of the shadow of the tower AB when the sun is at angle of 30 degree. Got it? In the second case, the sun has gone to an altitude of 60 degree angle. Now sun location has been changed, so the location of the shadow has also been changed. Now the shadow at 60 degree has been shrinked. Let's mark the shadow as BC. Initially the shadow was BD. Now shadow has been shrunk to BC. And the observer has noted that the difference between the shadow length is 40 meter in the two cases. It means this distance is 40 meter. Initially the shadow was BD, now the shadow is BC. So the difference between both the cases is 40 meter. Got it? So this is the scenario, and in this question we have to find the height of the tower. Very good question. In the previous question we have seen that two triangles are having the same base. In this question, you will see that the two triangles will have the common perpendicular. Okay. Here are you able to observe two triangles? First, the triangle is ADB, the big triangle with the angle as 30 degree. The second triangle is ACB with the angle as 60 degree. For the time being, let's take both the triangle out of the figure. For simplicity, let's mark the height of the tower as H, AB as H, and the distance BC as X. Just for the simplicity, you can proceed otherwise too. So here these two triangles are sharing the common side AB. For both of this triangle, AB is the perpendicular. For the triangle ABC, AB is perpendicular and BC is base. For the big triangle ADB, AB is again the perpendicular and BD is the base of this triangle. Okay. So let's take the triangle ABC and let's apply the trigonometric formula. Here let's use the formula of tan theta, which is perpendicular upon base. Why we are using tan theta? Because here we have to find the height of the tower. That is AB, that is perpendicular, and further the base is also coming into the picture as the length of the shadow is given in the question. Length of the shadow in both the triangle is the base. So base and perpendicular are coming into the picture, that is governed by the tan theta. Tan theta is perpendicular upon base. That's why we have taken the tan theta. So here tan 60 degree is equal to AB upon BC, which is H upon X. So we got tan 60 degree is equal to H upon X. Let's also refer the trigonometric ratio table for the value of tan 60 degree, which is root 3. So we got root 3 is equal to H upon X. Let's solve for H. We got H as X root 3. Here H is the perpendicular, which is the distance AB for this triangle. And if you observe, both the triangle are sharing the common perpendicular, that is AB is common in both the triangle. So let's take the value of AB, that is X root 3, also applicable for the second triangle. So let's go to the second triangle, the triangle ABD, and let's apply the trigonometric ratios formula in this triangle. Here AB is the perpendicular and BD is the base. And just now we have seen the perpendicular H is equal to X root 3 and BD, that is base, is composed of two line segment. If you refer the main figure, here BD is this complete length which is composed of DC plus BC. and DC is 40 meter and BC is x meters. So the complete length BD will be equal to x plus 40. Got it? We got the perpendicular as x root 3 and the base as x plus 40. Now let's apply the trigonometric ratio of tan theta. Why? Because again here perpendicular and base are coming into the picture, and the relation governing the perpendicular and base is tan theta. So we got tan theta is equal to perpendicular upon base. So tan 30 degree is equal to AB upon BD, which is equal to x root 3 upon x plus 40. Okay, we have simply replaced perpendicular and base with their respective values. Let's refer the trigonometric ratio table for the value of tan 30 degree, which is equal to 1 upon root 3. Tan 30 degree is equal to 1 upon root 3. So let's solve this equation for the value of x. On solving, we got the value of x as 20. Further in the question, we have to find the height of the tower, that is h, and h is equal to x root 3. Let's put x as 20. We got h as 20 root 3. Therefore, the height of the tower is 20 root 3 meter. That is the answer of the question. Got it? Here both the triangles are sharing the same perpendicular. So we have solved both the triangles separately with the perpendicular as common. That is h. And finally, we have equated both the triangles with the common perpendicular. Interesting question. We have done with this question. Let's move to the next question. The question is, the angle of depression of the top and the bottom of a 8-meter tall building from the top of a multi-storied building are 30 degree and 45 degree respectively. Find the height of the multi-storied building and the distance between the two buildings. So this is the question. This question is talking about the angle of depression. The previous questions we have done, all those questions involve the angle of elevation. That is when we are looking upward. Here the angle of depression is coming into the picture. That is we are looking downward. Let's see what is given in the question. In the questions, two buildings are given. One is a multi-story building and one is a small building. And the height of the second building is given as 8 meter, which is a small building. And the angle of depression from the top of the multi-story building to the top and the bottom of the small building is given as 30 degree and 45 degree respectively. It means from the top of this multi-story building, we are looking downward toward this small building. We are looking at 2 points. Firstly, we are looking at the top of that building, and secondly, we are looking at the bottom of the building. When we are looking at the top of the building, the angle of depression formed is 30 degree, and when we are looking at the bottom of the building, the angle of depression formed is 45 degree. And what is the angle of depression? It is the angle when we are looking downward, and it is formed between the line of sight and the horizontal line. Do not be confused with the vertical line. Do not take these angles at the vertical position. That will be wrong one. This is a common mistake done by the students. Further, let's mark the height of the multi-storied building as PC. P is the top and C is the bottom. And also mark this building as A and B. A is the bottom part and B is the top part. And also let's take this point as Q just to denote the angles. Here the angles are 30 degree and 45 degree. Let's form a straight line from the point B toward the PC. Let's mark this point as T. Here AC, BD and QP, these three line segments are parallel to each other, as these three are the horizontal line. Can we say these two angles are equal to each other? That is, this angle is 30 degree, so this angle will also be equal to 30 degree. And also these two angles are equal. If this angle is 45 degree, this angle will also be equal to 45 degree. Think, why these angles are equal? The same concept, just the hint we have covered in the theory part. Here the concept of transversals will be applicable. If we take QP and BD as the two parallel lines and BP is the transversal, we can say these two angles are the alternate angle. And in case of the transversal, the alternate angles are equal. So these two angles, that is 30 degree, will be equal to each other. Got it? Similarly, if we take QP and AC as the two parallel line and PA as the transversal, then these two angles are the alternate angle which will be equal to each other. This is the important concept and mainly used with the angle of depression. Mainly angle of depression are given on the top side and the triangle formed is on the bottom part. So somehow we have to transfer this top angles to the bottom part. And here our concept of transversals comes to picture. Okay. So this is the concept and just note it down. This is very important. Let's further solve this. Here, are you able to observe these two triangles? The triangle PBD and the triangle PAC. In the triangle PBD, our trigonometric angle is angle 30 degree, and in the triangle PAC, our trigonometric angle is 45 degree. And the interesting thing is that both the triangle are having the same base. How? For triangle PBD, the base is BD, and for the triangle PAC, the base is AC. And here BD and AC are equal to each other. That is, these two line segments are equal. So both the triangle are sharing the common base. So the approach that we will use to solve this question is, firstly we will solve this triangle and find the BD, then we will solve this triangle and find the AC, then we will equate BD and AC as both are equal to each other. Or we can solve the triangle PBD and find BD and put the value of BD in the second triangle. Whichever approach is convenient to you, we can use that. Got it? So you got the basic approach how to solve the question. Rest is just the simple mathematics. So let's take the triangle PBD. Here base is BD and PD is the perpendicular. Here tan theta will be applicable as perpendicular and base are coming into the picture. So tan theta is equal to perpendicular upon base. So tan 30 degree will be equal to PD upon BD. And what is the value of tan 30 degree? It is 1 upon root 3. So we got 1 upon root 3 is equal to PD upon BD. On solving, we got BD as equal to PD into root 3. Okay, we have solved for the value of BD. Why? Because in the second triangle also the base is same. So we can use this value to solve for the second triangle. Let's see how this is applicable. Let's take the triangle PAC. Here again, let's apply tan theta, which is perpendicular upon base. So tan 45 degree will be equal to PC upon AC. And the interesting thing with the tan 45 degree is that perpendicular and base will be equal to each other. How? Let's see. Tan 45 degree, the value is 1. So we got 1 is equal to PC upon AC. That is PC is equal to AC. That is perpendicular is equal to base. This is very interesting with 45 degree angle. Perpendicular and base both are equal to each other. So we got PC is equal to AC. And just now we have discussed that AC and BD both are equal to each other. AC is equal to BD. If we compare both of this equation, we got BD is equal to PC. Got it? We have just compared both of this equation. We got BD is equal to PC. BD is the distance between the two buildings and PC is the height of the multi-story building. Both are the missing dimension that we have to find in this question. Further, we have just calculated BD as PD root 3. So let's replace BD with PD root 3. Further, if you observe PC, the height of the multi-story building, it is composed of BD and DC, the two components. PC, it is composed of PD and DC. So we can replace PC with PD plus DC. The simple mathematics, nothing special we have done. We have just replaced PC with PD plus DC and we have replaced BD with PD root 3. Got it? Further, what is DC? If you observe the main diagram, DC is the height of the second building, the small building, which is given as 8 meters. So we can replace DC with 8 meters. So we got PD root 3 is equal to PD plus 8. Now we got an equation in which only one variable is there, that is PD. Let's rearrange the equation and solve for PD. We got PD as 8 upon root 3 minus 1. Here we can put root 3 as 1.732 and solve this equation. But in the question it is not given the value of root 3, but we can use that. But here we will use the alternative method. That is, we will use the rationalization. Let's multiply the numerator and denominator with root 3 plus 1. Here in the denominator, we got root 3 plus 1 into root 3 minus 1, which is resembling a plus b into a minus b, which is a square minus b square, the simple algebra. So on solving, we got PD as 4 into root 3 plus 1 meters. So let's find the height of the multi-story building, which is PC, and PC is equal to PD plus DC. And just now we have calculated PD as 4 into root 3 plus 1 and DC is equal to 8 meter. So our answer, that is the height of the multi-story building, will be equal to 4 into root 3 plus 3. The simple mathematics we have applied. The second part of the question is demanding for the distance between the two buildings, and distance between the two buildings is AC, which is equal to PC, and just now we have calculated the PC. So AC, that is the distance between two buildings, is also equal to 4 into root 3 plus 3. That is the answer of the question. Got it? So the understanding that we got from this question is that whenever we are having the question of angle of depression, in those cases we have to look downward. That is, angle of depression is looking downward and angle of elevation is looking upward. The second thing is that whenever we are having angle of depression, the case of transversal and the alternate angle will come into the picture. And you have to transfer the angle at the top to the bottom part so that you can use the trigonometry in the below triangles. So this is the understanding about the angle of depression that you got from this question. We have done with this question. Let's move to the next question. A 1.2 meter tall girl spots a balloon moving with a wind in a horizontal line at a height of 88.2 meter from the ground. The angle of elevation of the balloon from the eyes of the girl at any instant is 60 degree. After some time, the angle of elevation reduces to 30 degree. Find the distance traveled by the balloon during the interval. So this is the question. Let's observe the question. In the question, a 1.2 meter tall girl is given and she is observing a balloon in the sky. A balloon is traveling in the sky and at a certain point she has observed the balloon in the sky. The angle of elevation found is 60 degree. Angle of elevation is the angle between the line of sight and the horizontal line. The girl is looking at the balloon, so this is the angle of elevation which is given as 60 degree. The balloon is flying at a height of 88.2 meter from the ground and the height of the girl is 1.2 meter. Further, after some time the balloon has traveled some of the distance and now again the girl is looking at the balloon. Now the angle of elevation has been changed to 30 degree. Initially at the first point the angle of elevation is 60 degree. After some time balloon has traveled the distance. Now the angle of elevation has been reduced to 30 degree. Got it? This is the scenario. And in this question we have to find the distance traveled by the balloon. That is the distance between these 2 points. Okay. So this is the scenario given in the question. Here let's mark the different points as A, B, C, D, E, F and G. These are the different points. Here are you able to observe the different triangles in the given figure? These two triangles are the right angle triangle in the given figure. Firstly the triangle ABE and the second is the triangle ACD. These are the two right angle triangles. Here the height of the girl is given as 1.2 meter and the balloons are flying at a distance of 88.2 meter. So can we say this distance is 88.2 meter minus 1.2 meter? It will be 87 meter. So these two distances BE and CD will be equal to 87 meters. That are also the side of these two triangles. And further we have to find the distance BC. So the approach that we will use is from the triangle ACD we will find AC, the side of the triangle, and from the triangle ABE we will find the side AB, and AC minus AB will be equal to BC. That is the distance that we are looking for. So this approach we will use. For that we have to apply the trigonometric ratio formula in both the triangle. Firstly let's take the triangle ABE, this triangle. Here the trigonometric angle is 60 degree and BE is the perpendicular opposite to trigonometric angle and AB is the base of this triangle. So which trigonometric ratio will be applicable here? Here tan theta will be applicable as perpendicular and base are coming into the picture. So tan theta is equal to perpendicular upon base. Tan 60 degree is equal to BE upon AB. And BE we have just calculated as 87 meter. And what is the value of tan 60 degree? It is root 3. So we got AB as 87 upon root 3 meter. We got one part of the question, that is AB is equal to 87 upon root 3 meters. Further, let's take the second triangle, the triangle ACD. Here the perpendicular is CD, which is the side opposite to a trigonometric angle 30 degree, and AC is the base of this triangle. Here again tan theta will be applicable, which is perpendicular upon base. So tan 30 degree is equal to CD upon AC, and CD it is given as 87 meter that we have just calculated. And what is the value of tan 30 degree? Think it is 1 upon root 3. So we got 1 upon root 3 is equal to 87 upon AC. We got AC as 87 root 3 meters. Again, you should know the trigonometric ratio values for tan 30 degree, tan 45 degree and tan 60 degree. 90% of the time these three trigonometric ratios will be applicable. It does not mean you should skip the other trigonometric ratio values. You should know the complete trigonometric ratio table. Okay, so we got AC as 87 root 3 meters and AB as 87 upon root 3 meters. And in this question we have to find BC, which is equal to AC minus AB. Let's put the value. Let's take root 3 as the LCM. On solving, we got the answer as 174 upon root 3. We can further solve this. Let's multiply the numerator and denominator by root 3. On solving, we got our answer as 58 root 3. So we got the distance traveled by the balloon is 58 root 3 meters. That is the answer of this question. We have done with this question. Let's move to the next question. The question is, as observed from the top of a 75-meter high lighthouse from the sea level, the angles of the depression of the two ships are 30 degree and 45 degree. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. So this is the question. Let's observe the question. This question is talking about a lighthouse of height 75 meter. And from the top of the lighthouse, an observer has observed two ships in the sea. We are having two ships in the sea, one behind the other. It means the observer is looking down toward the two ships from the top of the lighthouse. Angle of depression when we are looking downward, and this angle is with respect to the horizontal line. So these two angles are the angle of depression, which are 30 degree and 45 degree. Further in the question, we have to find the distance between the two ships. This distance we have to find in the question. So this is the question. Let's see how we approach the question. A point that you should note is that whenever we are having a question with angle of depression, the angle of depression are formed at the top point as we are looking downward. So these angles are formed at the top point. Somehow we have to transfer the angle from the top portion to the bottom portion because our triangles are formed at the bottom portion. So whenever we are having the case of angle of depression, we have to transfer the angle from the top to the bottom triangles. How we will do that? We will take the help of the transversals. Transversals and the parallel line, the concept you must have done in the previous classes. We will use the concept of transversal in which the alternate angles will be equal to each other in case of the parallel line. As we will take down the question in detail, you will understand it more. Okay, so let's approach the question. Let's give the name to the various points as A, B, C, D and P. AD is the height of the lighthouse, which is given as 75 meter. Point C is the point of the first ship and point B is the point of second ship. Further, here are you able to observe the two triangles, the triangle ABD and the triangle ACD. Here in this triangle we do not know the trigonometric angle. So through the help of the transversals and the parallel line, we will find the trigonometric angles for both the triangles. Let's see. Here can we say BD and AP both are parallel to each other? BD and AP both are horizontal lines, so they will be parallel to each other. And can we say AB is the transversal? Let's take these three line segment out of the figure. Here AP and BD both are parallel to each other and AB is the transversal. And in case of transversal, the alternate angles are equal. So these two angles will be equal to each other. This angle is 30 degree, so this angle will also be equal to 30 degree. the simple concept of transversals we have used. Similarly, if we take the line AC as a transversal and AP and BD are the parallel line, can we say these two angles will be equal to each other, as these angles are the alternate angles in case of transversals. So we got this angle as also equal to 45 degree. Got it? Whenever you are having the question of angle of depression, you have to transfer the angle at the top to the bottom portion. The same we have done here. We have transferred the angle at the top to the bottom portion so that we can apply the trigonometric ratio in these triangles. So whenever you are having the angle of depression in the question, you have to apply the concept of the transversal and the alternate angle. Note that this is very important. Further, we got the trigonometric angle for both the triangle. For the triangle ABD, our trigonometric angle is 30 degree, and for the triangle ACD, our trigonometric angle is 45 degree. And in the question, we have to find the distance BC, that is the distance between the two shapes. So the strategy that we will use is, firstly, we will take the triangle ABD and we will find the distance BD, the complete length BD. Then we will take the triangle ACD and we will calculate the distance CD. And BD minus CD will be equal to BC. Got it? This is the approach that we will use to find the distance BC, or the distance between the two shapes. So let's take the triangle one by one. Firstly, let's take the triangle ACD. Here AD is the perpendicular as it is opposite to the trigonometric angle, and CD is the base for this triangle as this is the side between the trigonometric angle and 90 degree angle. So which trigonometric ratio will be applicable, or which trigonometric ratio is the linking between the perpendicular and the base? It is tan theta. So here tan theta will be applicable, which is equal to perpendicular upon base. So tan 45 is equal to AD upon CD. And AD it is given as 75 meters, and the value of tan 45 degree we know it is 1. So we got CD as equal to 75 meter. Got it? We got the CD, the base of this triangle, the one component. Let's go to the second triangle, the triangle ABD. Here our trigonometric angle is 30 degree and AD is the perpendicular, which is the side opposite to trigonometric angle, and BD is the base, which is the side between the trigonometric angle and the 90 degree angle. Here also tan theta will be applicable, which will link the perpendicular with the base. So tan theta is equal to perpendicular upon base. Tan 30 degree is equal to AD upon BD, and AD it is 75 meter, that is given in the question. And what is the value of tan 30 degree? It is 1 by root 3. So on solving, we got BD as equal to 75 root 3. Got it? We got the base of this triangle. So we got CD from the first triangle as 75 meter and BD from the second triangle as 75 root 3. And in the question we have to find BC, which is equal to BD minus CD, which is 75 root 3 minus 75. So we got our answer, that is BC as 75 into root 3 minus 1 meters. That is the answer of the question. Got it? The better you are able to visualize, the better you will be able to solve the question. Here the learning that you got from this question is that whenever you are having the angle of depression, the concept of transversals and the parallel line will be used. We have done with this question. Let's move to the next question. The question is, the angle of elevation of the top of the building from the foot of the tower is 30 degree and the angle of elevation of the top of the tower from the foot of the building is 60 degree. If the tower is 50 meter high, find the height of the building. So this is the question. Let's observe this question. In this question, a tower and the building is given. The height of the tower is given as 50 meter and the height of the building is missing, that we have to calculate in this question. Further, the angle of elevation of the top of the building from the foot of the tower is given. It means we are looking at the top of the building from the foot of the tower. The angle formed is 30 degree with respect to the horizontal line. Further, the second angle of elevation is also given. In this case, we are looking at the top of the tower from the foot of the building, and the angle formed is 60 degree. Got it? When we are looking at the top of the building from the foot of the tower, the angle formed is 30 degree, and when we are looking at the top of the tower from the foot of the building, it is 60 degree. Got it? So this is the scenario given in the question. We have to find the height of the building. So let's proceed. Let's mark the point as A, B, C and D. AB is the building and CD is the tower. Here are you able to observe the two triangles in the given figure, the two right angle triangle, the triangle ABC and the triangle BCD. These two triangles are the right angle triangle and both the triangles are sharing the common side BC. That is the base of both the triangle. In the triangle ABC, the trigonometric angle is 30 degree. AB is the perpendicular as it is opposite to trigonometric angle and BC is the base for this triangle. And for the triangle BCD, CD is the perpendicular as it is opposite to trigonometric angle 60 degree and BC is the base of this triangle. BC is common in both the triangles. That will help us in solving this question. Firstly, let's take the triangle DBC. Here we will use tan theta as it will link the perpendicular and the base. Tan theta is equal to perpendicular upon base. So tan 60 degree will be equal to CD upon BC. CD is 50 meter, that is given, the height of the building. What is the value of tan 60 degree? It is root 3. So on solving, we got BC as 50 upon root 3 meter. We got the BC, that is the base of this triangle. Further, let's take the triangle ABC, which is sharing the common base BC. We can use the value of BC that we got from the first triangle in the second triangle. Here the base of this triangle is BC, which we have just calculated as 50 upon root 3. And AB is the missing dimension. Our trigonometric angle is 30 degree. So here also we will use a tan theta, which will link the perpendicular with the base. So tan theta, which is perpendicular upon base, will be used. Tan 30 degree will be equal to AB upon BC. BC let's replace with 50 upon root 3. And what is the value of tan 30 degree? It is 1 upon root 3. Let's solve this equation. We got AB as 50 upon 3 meter. That is the answer of the question. The height of the building we got as 50 upon 3 meter. We have done with this question. Let's move to the next question. The question is, a straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at an angle of depression of 30 degree, which is approaching the foot of the tower with a uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degree. Find the time taken by the car to reach the foot of the tower from this point. So let's observe the question. In this question, a tower is given on the highway. Let's have a tower. On the top of the tower, the man is observing the road. A car is coming toward the tower. That man is also observing this car. The angle of depression formed is 30 degree. Angle of depression when we are looking downward. This man is looking downward toward the car. And this angle is with respect to the horizontal line. So this angle is 30 degree when this man is looking from the top of the tower to the car at the road. Further, after a 6-second gap, the car has moved toward the tower. Now the angle of depression has been changed to 60 degree. Initially the angle of depression is 30 degree. After 6 seconds, car has traveled some distance. Now the angle of depression has been changed to 60 degree. And in this question, we have to find the time taken by the car to reach the foot of the tower. So basically we have to calculate the time this car will take from this point to this point. Let's take the various points as A, B, C, D and E. Here we have to calculate the time that we will take at the end of the question. Firstly, let's apply the trigonometric fundamental. Here the angle of depression is given, angle of depression when we are looking downward, and this angle is with respect to the horizontal line. Don't confuse it with the vertical line, a common mistake done by the students. So here 30 degree and 60 degree are the angle of depression. And here we have to transfer these angles to the bottom part of the figure. How we will do that? We will use the same fundamental that we have done for the previous questions related to the angle of depression. We will use the transversals and the parallel line concept. Here AE and BD are the two horizontal lines, so these two lines will be parallel to each other. If we take AB as a transversal, can we say these two angles are equal to each other? Yes, if AB is the transversal and AE and BD are the two parallel lines, These two angles are the alternate interior angle. So these two angles will be equal to each other in case of the parallel line and the transversal. So this angle is also equal to 30 degree. Similarly, if we take AC as a transversal and again AE and BD as a parallel line, these two angles will be equal to each other as these angles are alternate interior angles. Got it? So we got this angle as also equal to 60 degree. So we have applied the concept of transversals and the parallel line. Whenever you are having the angle of depression, you have to transfer the angle at the top to the bottom part, because at the bottom part we will have our triangles that you will see next. So you should note this concept every time whenever we are having the angle of depression, we have to apply this concept. Further, we got the two angles. Are you able to observe two right angle triangles in the figure? Here the triangle ACD is a right angle triangle and the triangle ABD is the right angle triangle. For the triangle ACD, our trigonometric angle is 60 degree, and for the triangle ABD, our trigonometric angle is 30 degree. Here if you observe, both the triangles are sharing the common side as AD. Here AD is common in both the triangle. So the approach that we will use is, we will apply the trigonometric ratio in both the triangle and we will find the distance AD or the side AD. As AD is equal in both the triangle, so we will find AD in both the triangle and equate the value of AD that we got after applying the trigonometric ratio formula. So basically we have to find AD in both the question, and after that you have to equate the value of AD. So this approach we will use in this question. Note that here no dimension is given. We do not know the height of the tower. We do not know the distance between the car or any of the side of the triangle. Only data that is given is the 30 degree and 60 degree angle and 6-second gap between the point B and C. Do not do the mistake of taking the 6 second as a distance. Here the distance between B and C we do not know. The distance between B and C is not given in the question. Only the time is given between the point B and C. The car has taken 6 seconds to reach from B to C. This is 6 seconds. Second is the unit of time, not the distance. So don't be confused with this. Okay. And in this question, we have to calculate the time taken by the car from point C to point D. That is again in the unit second, not in the meter or in the distance term. So this you should observe. Okay. So let's take the triangle ABD and let's apply the trigonometric ratio formula. Here AD is the perpendicular as it is opposite to our trigonometric angle 30 degree, and BD is the base as it is between our trigonometric angle and 90 degree angle. So here we will apply the trigonometric ratio of tan theta. Why? Because here perpendicular and base are coming into the picture, and the only trigonometric ratio that link perpendicular and the base, it is tan theta. That is tan theta is equal to perpendicular upon base. So we got tan 30 degree is equal to AD upon BD. And what is the value of tan 30 degree? This you should know, it is 1 upon root 3. So on solving, we got AD is equal to BD upon root 3. Got it? We got the value of AD. Further, let's also find the value of AD from the second triangle, that is from the triangle ACD. Here AD is a perpendicular and CD is the base. So again tan theta will be applicable, that is perpendicular upon base. Tan 60 degree is equal to AD upon CD. And what is the value of tan 60 degree? Think, it is root 3. So let's solve for AD. We got AD as CD root 3. From the first triangle, we got AD as BD upon root 3. From the second triangle, we got AD as CD root 3. So let's equate both the values. We got BD upon root 3 is equal to CD root 3. On solving, we got BD is equal to 3 times CD. Further, if you observe the figure, here BD is this complete distance, which is composed of two parts, BC and CD. So we can replace BD with BC plus CD. On solving, we got 2CD is equal to BC. That is, BC is 2 times of CD. Further, in the question it is given the time taken by the car to travel from point B to C, it is 6 seconds, and we have to calculate the time taken by the car to reach from point C to D. Here we got BC is twice of CD, or we can say CD is half of BC. If the car is taking 6 seconds to reach from point B to C, then how much time it will take to reach from C to D? It will take half of the time. Got it? CD is half of BC. If the car is taking 6 seconds from reaching B to C, it will take half of that time to reach from C to D. That will be 3 seconds. 6 by 2, that is 3 seconds. But here we will not go by logic. We will apply some mathematical formula. The formula is speed is equal to distance upon time. This is a basic formula of speed that you must be knowing. Speed is expressed in kilometer per hour. Kilometer is a distance and hour is the time. So you must be knowing speed is equal to distance upon time. This is a basic formula that will be applicable here. From this formula we got time is equal to distance upon speed. We have done so because in the question we have to find the time taken by the car to travel the distance CD. This is a basic formula, do not worry, only the basic formula we are using, no special high-fi formula we are going for. This is very simple, just pay your attention please, okay? If we take the distance BC, we can use time is equal to distance upon speed formula. Time, it is given as 6 seconds for the car to travel from B to C, that is distance BC. Here distance is BC, let's take it as BC. And what is the speed that the car has traveled? It is not given in the question, but in the question it is given the car has traveled with the uniform speed. So let's take the speed as S, just as the uniform speed. Here we can rewrite this as BC is equal to 6S. Further, let's also apply the same formula of time in the distance CD. Time is equal to distance upon speed. Let's take the time as T, the time that we have to calculate, and the distance as CD. And what is the speed? The speed of the car is uniform from the point B to D. The speed at which the car is traveling from B to C is the same speed at which the car is traveling from C to D. So again the speed will be S, the same speed that we have used in the first case. Okay. Here can we replace CD with BC upon 2? We have used this equation, 2 times CD is equal to BC, or CD is equal to BC upon 2. Further, we can also replace BC with 6S from this equation. Here S and S will cancel out, that is the speed is uniform, that is the helpful hint given in the question. S and S, that is the uniform speed, will cancel out. We got our answer as 3 seconds. 6 upon 2, that is 3 seconds. So that is the answer of the question. So you must also know some of the basic formulas of speed, distance and time. The basic formula you must be knowing to solve this question. We have not done anything special. We have simply applied the basic speed distance formula. So students, we have done with this lecture. Hope you have enjoyed our new and creative way of teaching. If so, like the hit button, subscribe to our YouTube channel and also share this video with your friend. And do not forget to download the PDF of the concept and the formula list, and also check the link to the quiz in the description. So that's it for this video. Thank you very much for being with CREATA Classes. Bye for now, best of luck and have a great day.